Hello, this lesson is for my pre-calculus students. We're going to be doing lesson 43 today on page 219, 220, and 221 if you wish to follow along. Learning today about what's called integration and what is called an antiderivative. An antiderivative is the opposite of a derivative. We know that we can take the derivative of a number, any number they give us, as like x squared. If I take the derivative of x squared, the 2 jumps to the front, and I subtract 1 from this 2, and I get 2x to the 1. Anti-differentiation, or finding the antiderivative, is they give you the 2x, and they want you to go backwards. And they say, what was this the derivative of? So in the very first portion of the lesson, they're showing you that they take the derivative of x squared, they take the derivative of x squared plus 42, they take the derivative of x squared minus 165, and every single time they get the same derivative, they get 2x. The fact that you can have all these different functions and the derivative of each of them is the same number is important. We'll come to that in a minute. So look at example 43.1. It says if f of x equals 2x, find the function, and then they use this. They use an uppercase F. They use a capital F. Anytime you're given, here's your function and here's this, this is telling you they want the antiderivative. What is this the derivative of? And in a later lesson, we'll go about how you find out what that is. This lesson here doesn't really go into the process of it. But they say, oh, well, we showed you that the derivative of x squared was 2x, so if I'm asking for the antiderivative of 2x, you know that it is x squared. And then the book, as their answer, puts down something strange. They put down minus 463. Where did they get that 463 from? That negative 463 from? They just pulled it out of thin air. This could have been any number whatsoever. Above that, they show, what is the derivative of x squared 2x, the derivative of x squared plus 42 minus 165 minus 463. You put any constant out here, and you take the derivative of this. The derivative of whatever the constant is always 0. So you could have made this 463.72814 pi. It doesn't matter. This number out here is totally irrelevant. So what they will do from now on is when they write this antiderivative, they will write it as x squared plus c plus some constant. Okay? Could be any number. All right? Excuse me. Go to the bottom of the page, page 219, and the top of the next page. They talk about what's called integration. Integration is this finding the antiderivative. It's the word that's used for it. And they have a symbol for it. Some people say it looks like an S. My calculus professor at Wheaton, Dr. Terry Croissant, I think he told us that was like the Greek letter delta, the lowercase delta, uppercase delta, lowercase delta. So I don't know. You don't have to draw it looking like a D or an S. Some people just write a wavy line. Doesn't matter. When you see that symbol, it's telling you go find the antiderivative. And they go through a little bit of explanation of the difference between a derivative and a differential. We're not going to worry about that right now. We're just going to jump right down to example 43.2. And it says differentiate cosine x. Now, right above that, it says, in bold type, it says something about, trying to guess. And it says finding the integral of a function requires the ability to guess the answer based on experience with derivatives and everything. So before we do this, let's just stop for a second. And if sine is my function, what is the derivative of sine? And I'm just going to use f prime of x. Derivative of sine is cosine. I've mentioned this at least twice in videos. We never covered this in a lesson, but it's kind of being picked up here. The derivative of cosine, or the second derivative, is negative sine. And the derivative of negative sine will be negative cosine. And if you take the derivative of that, fourth derivative, you're back to sine. The derivative of sine is cosine. The derivative of cosine, negative sine. Derivative of negative sine, negative cosine. And so it just goes right around, almost like Euler's notation. I squared, I cubed, I to the fourth. I to the fifth is the same as I, and you go back and forth. So that's good to know. So what had cosine as its derivative? In other words, what's one step above cosine? This is going to be the sine of x. Now the book is going to put plus c there because it could have been the sine of x plus 17. The sine of x plus 17 is, when you take the derivative of that, the derivative of sine of x is cosine x. The derivative of 17 is 0. Okay, so we're good. The second one says 43.3, the integration of negative sine t. What had negative sine as its derivative? Now look over here. The antiderivative of negative sine is cosine. And it would be cosine t, and then again plus c. Let's just go ahead and add that. Top of the page, it says the integration of e to the x. Now I don't have it up here, but what had e to the x as its derivative? Well, the derivative of e to the x is e to the x itself. Okay? Oops, I dropped my chalk. So, yeah, if I take the derivative of e to the x, I get e to the x. If I take the derivative of e to the x minus 4, the derivative of negative 4 is 0. So we're back over here. Okay? Last one. It says, if dy over dx equals cosine x, find y. Okay? Your derivative is cosine x. What had cosine x as its derivative? And we're back over like we were with the 43.2 example. It's just this. It's just sine of x. And in a later lesson, I will show you how to find something, how to find these derivatives. Right here, we were just working with these ones that we have memorized. But you know, if it said if f of x equals 2x, what is f of x? Well, we said that's x squared. Well, if f of x equals 3x, what's that? Is it x cubed? It is not. We'll deal with that in a later lesson.